Hi students, welcome back. So in the previous video we are discussing the acid properties. Acid properties. So in that we had seen what is atomicity. So now let us see what is consistency. What is the consist. So in that video we had seen that atomicity means it is it must be atomic. Means it has to do all the operations or nothing will do. Now coming to the consistency. So consistency is nothing but correctness. So you call it as a correctness. That means that the integrity constraint must be maintained so that database is in always consistent state before or after transaction. Okay, so it is saying that the consistency you call it as a correctness, that the integrity constraint must be maintained so that the database whatever you're using that should be always in consistent state before or after transactions. So you have to make sure after the transaction also this should be in consistent state. So let us take the example. So in the previous example we had taken two accounts A and B. A is having the amount as 500 and B in account there is a 200 amount. Okay, suppose sum of A comma B is equal to sum of A comma B, means before transaction should always equal to after transaction. Then you can say that your database is in consistency state. So before transaction A is 500 and B is 200. So after transaction A is 400, 100 is deducted and is transferred to B 300. So 700 is equal to 700. Then you can say that the database is in consistent state. Okay, so this is about the consistency. So this is the second property. Now coming to the third property, isolation. So what do you call this isolation? It's nothing but it indicates that the actions performed by a transaction will be isolated or hidden from outside the transaction until it terminates. So simply isolation is transactions should be in isolation. It cannot be visible to other transactions until it completed. Okay, until one transaction is completed, you cannot show that transaction to another transaction. It should be in isolation state. Okay, so let us take one example for explaining the isolation. Suppose T1 is one transaction, T2 is another transaction. Okay, so let us take for all this the same example, the bank example. So first read A value. So A value contains 500 before. So now A minus 100. So we deducted 100 rupees from account A. Then you write A. Okay. So next read B plus 100 and write B. So this is another transaction. So means this is completely one transaction. It says that you are transferring the amount, okay, 100 rupees from here to here. Okay, so after transaction this value will becomes the 200 plus 100 300 and here it is 400. Okay, so then it maintains the database in consistent state. Here the isolation means suppose after completion of this another transaction is started. It's saying read X. So read A. So A value is 400. Okay, and then read B. B value is not 400. Okay, 400 it is written 400. Okay, because it is minus a is 500. 500 minus 100, 400. So it is already write the a, means it commits the value of a in the account. Okay, the a account is committed. So read x means it only reads the 400, not 500. It doesn't read the previous before value. After the commit, it reads the committed value. So 400. B value is 200. So a plus b means here 600. Okay. So did you find the difference here? If the transaction is not completing, if the data used during execution of a transaction is not completed, so in between this another transaction is seeing this data, okay, and it is performing the operation, and you will get another value, means the database in inconsistent state. So to avoid this problem, we are using the isolation technique. Okay, so isolation property. So what this isolation will do? The data used during execution, so whatever the data you use during execution of a transaction, so for complete transaction you are using one data. Okay, the data used during execution of a transaction cannot be used by second transaction until first one is completed. So until first one is completed, another transaction cannot be used those values. That you call it as isolation. Maintaining, you are hiddening the values of one transaction to another transaction, so that the database will not come to inconsistent state. To make the database as a consistency, so we are using isolation property. Means here the values in transaction 1 cannot be used by the second transaction until the first transaction completes its operation. Okay, so that is isolation. Now coming to the next property. So what is the next property? That is durability. Durability. So what do you mean by durability? Durability means all updates done by a transaction must become permanent. Okay, so whatever the updates and updations done by the transaction must become permanent, means it use the commit statement. Okay, so here the durability is saying that whatever the transactions you are done, and if it is updation is done, then it makes the transaction permanent. Okay, permanent means suppose the system fails, suddenly the system fails. If your database in using the durability property, that database will maintain the consistent state, means whatever the updations is done in the transactions will not be removed until you change. You have to be note that until you change. Until you change, the values in database will not be erased or removed. Okay, so that you call it as a durability. So these are the different acid properties. So here A, you call A is atomicity. So what this atomicity will do? Transactions will do or all or nothing. So atomicity is nothing but it uses the property as all or nothing. So what is C? Okay, what do you mean by C? C is the consistent state, means only valid data is saved. So that is C, the consistency. Next is I. I is nothing but isolation. So what this isolation will do? Transactions do not affect each other. So after completion of one transaction only, the another transaction will visible those see those values. So transaction do not affect each other. Okay. Now what is next is durability. So durability means written data will not be lost. That is about the durability. So these are the ACID properties, one of the important topic in the database management system: atomicity, consistency, isolation, and durability. Okay, so one thing here you can note that. So if your database in atomicity, isolation, and it following the durability property, obviously it follows it says your database in consistent state. If it is atomicity, isolation, and durability, then you no need to check for the consistency. If these three follows, then automatically the 4 will be there. That is, your database is maintaining consistent state. Thank you.